In this particular video of our three-part abstract class series, what we're going to do is build two child classes that implement the two abstract methods from the parent class. By doing that, we're going to be able to implement them as objects in our third video, which is in the main section of the project we're working on. So take a look. Okay, in this video, we're going to look at the first class that will extend the abstract class known as pet. So we've got a class that I've partially set up here known as kitten. And again, as always, you can see that I've got my header folded. I've generated constructors. We're going to talk about those in a minute. But first, I need to actually extend the class pet. So I'm going to, and let me pull up pet here. So you can see this is our pet class. And we have these two abstract methods that we're going to need to implement in kitten. So kitten only has one extra field as a specific child class of pet known as num lives left, because cats have 9 lives. But first we need to tell it extends pet. Okay? Now when we type extends pet, kitten comes up with an error and says, the type kitten must implement the inherited abstract method pet display pet. 2 quick functions available. Add unimplemented methods. If I click that, at the bottom it tosses in both headers for implementation of those 2 methods, making my work a lot easier. So let's take a look at what it did. First of all, it said @override. We use this annotation whenever we are instantiating or overriding a new version in the child of the parent. So if we are implementing the display pet method and giving it a body, we need the @override to tell the compiler, hey, go look at the parent's abstract, we're actually putting it in here. Or this pet might be a concrete class and we're just having a new version of it in the child. Okay? So in this case, override means we're actually implementing an abstract method. So for display pet, we're going to actually tell it what to do when it's called. So since I'm going to use a bunch of print statements, I'm just going to copy this in to save time. So basically we're just going to print a pet report, and you'll notice that I'm using the getters and setters from the parent as well as the child. Okay, and we'll talk about that again in a minute. For the return sound, all I'm going to do here, I'm going to get rid of my to-do list, and I'm going to say return meow. Okay? That's what it's going to return as a string when it wants to know what is the sound that a kitten makes. Okay? So, look in my, let's start with the constructors and see what's different. Okay? Let's play with the constructors. So we're properly chained. We're going to pass 0, no name set 0. And in kitten, we're going to pass 0, the name we've been given, and 0. But look in the full constructor. We're given the number of lives left, the name, and the age. But we pass to super the name and the age, because those fields exist in the parent class. So we're passing those values uphill to the parent class, and we're going to set the one that's located here in the child class. Okay? So child classes are always bigger than the parent class because we're adding stuff. We're adding nums live left. But we can still access those fields and those getters and setters. So in the child class here, you'll notice I only have one getter and setter. okay, for num lies left. Because I can still use the getters and setters in the pet class for the other ones. Here they are. They already exist. So I don't need to redefine them. I could, but I don't need to. If I did redefine them, they would have the override in front of them. Okay? So I have now implemented the two functions that are in pet, that are abstract, and I've added a field. So the kitten class, you can think of it as having everything the pet does and then a little bit extra. Okay? That is the kitten class. Now, let's open up the puppy class. And we're going to have some work to do in puppy. We're going to look at the constructors. Oh, no, we didn't chain them, did we? So let's do that as a review. Okay? I'm not going to call super. I'm going to call this. And I'm going to pass the number of bones hidden, the name, the age, and whether the puppy is neutered. So we'll pass false. And I can get rid of these. Now, in the partial constructor, we're given just the name. So I'm going to pass to this number of bones, name, because we're given that, and then age and false again. Okay? And I can get rid of these because I'm passing safe values and the one that I'm handed into this. Okay, so there's a partial constructor. Now for the full constructor, I'm going to pass name and age to the parent, and I'm going to assign number of bones hidden and whether it's neutered directly to the fields, because those are the two new fields of the puppy class. Okay, so now I've cleaned up my constructors and they look good. And for my getters and setters, I only need to get and set the two fields that I currently have. So I went ahead and auto-generated those so I can fold those up. So now we are left with our display pet function, which is an override, which is simply adding the new things for this particular pet. Okay, so it's going to show bones hidden and whether he needs aspirin because he got neutered. Okay, so that's different than the kitten class because there's different fields. And obviously, for the return sound, I'm going to return rough, right? Or a barking sound. Okay? So, what we've got is we have two different classes, puppy and kitten, that look similar. Okay, so that it makes sense that they both have a common ancestry of pet. But they each implement these two methods differently because they have different fields that are unique to them as puppy and kitten, and they have different sounds that they return. But and this is important when we start to talk about interfaces, puppy and kitten, it makes sense for them to have a common ancestry of pet. Okay? So that common parent class is the pet class. So anything that I need to know if I'm running a pet store about all the different pets, whatever's common to all of my pets, I'm going to put in the pet class. So then when I build the turtle class or the rabbit class or the goldfish class, I only need to worry about what's different. Okay? So we're already seeing that abstract classes can save me the writing of a lot of code because I can inherit all of the fields and all of the methods of the parent class. So it's less work for me to do when I have to differentiate between the different types of pets. So in the next video, we're going to actually build a kitten and a puppy so you can see exactly what we're talking about. So now you've seen how we were able to build two child classes from the abstract class that we started with. In the next video, we're going to create main, and we're going to start using at least one of each of those child classes. See you on the other side.